So first of all, Rebecca is trying to design a parallelogram. Now for her to design a parallelogram, first thing she does is she states that my paper's not big enough for me to draw a diagram with side lengths in meters. So right away she's looking at the image and saying, well, hold on a second, meters are just gigantic. So that should tie into the activity that you completed related to air hockey. Remember how the air hockey table, the table itself in real life is much bigger than the paper copy? Well, she's got the reverse issue, where she's got a paper copy with huge dimensions, but she needs to shrink it down so that she can actually draw it. So she starts describing her scale. If you look up on the screen, she describes her scale right there, where she says, I'll draw with a scale of 1 centimeters, or where 1 centimeter represents 1 meter. Then she can draw in centimeters instead of meters. And she's starting by drawing and labeling the 5 centimeter side. So the 5 centimeter side represents the 5 meter base. Good so far? Now, after she drew her base, she labeled it, and then she constructed a 110-degree angle at one end and a 20-degree angle past the 90-degree mark. 110 degrees is 20 degrees past. So what does that look like? So when you look at this protractor, for example, all measurements start from the vertex, and if we're going to measure an angle, we need the lower arm of the angle, or one ray from the angle, to have its vertex right at the main intersect of the protractor. Meaning, if you were to imagine that the protractor is like the sun, then the sun's horizon could be right here, and these are the rays of the sun, or this could be the sun, and then all the sun's rays shoot out from the sun. All of those rays are considered angles, or could be marked as angles on the protractor. Can everybody see the sun?
Yes.
Okay, so when you're trying to develop your angle, you have to position your protractor so it goes over top of, the center point goes out over top of the vertex, right here. Can you see the yellow, or is it too bleached? So you'll notice that the vertex of the angle matches the center point of the protractor. Now, when you're reading your angles, the way to read the angle, just to review it quickly, is to use the arm that's pointed toward the bottom of the protractor. It's actually right here. It's sitting horizontal. That arm is our zero arm. Whatever arm is pointing along the horizontal of your protractor is your zero arm, and that should point toward 0. So this arrow is pointing to the 0 line on the protractor here. That means we start counting from 0, and we go from this position all the way to the other arm. And it's the distance on the protractor from the 0 up that tells us what number to use. So that could either be 60 or it could be 120. How do you know which number to use? Movin?
You have to look at the angle. If it's like, okay, it's straight, this like square, half a square. But if it's like a little more bending, like low half a square, you can use the 61. But if it's a bit more than half a square, you can use 120.
Okay, so you're using your 90-degree angle as a reference point. That works, yes. Sajid?
If you see that, you know, the horizontal line, if you check which side it's on, actually, if it's on the left, then you're counting up from the 0 that's on the left and not the 0 that's on the right. Because obviously the horizontal line is actually being there, and you go up from there. If it's on the other side, then you start from the 0 on the bottom marks there we measured that.
Okay, so to follow what you're saying, that means if we were to start with the 0 over here and count to this line, we would find that this angle all the way from that side of the protractor to the ray, is actually 120 degrees. Right? But that's not what we're measuring. We want to know this angle in here. It would have to be 60 degrees. Now, how do you know it has to be 60 without even reading the protractor? Adit.
Because it's the protractor is a semicircle, and all circles have a 360-degree angle. So half of a circle, a semicircle would have to have 180 degrees. So then, if one side's 120 degrees, then if you take 120 degrees to 180 degrees, you get the 60 degrees.
Everybody get it?
Yes.
Make sense? So Adit's describing complementary angles. Complementary angles are angles that when combined will give you a straight angle. So we've got two. Like Bhuvan said, if the angle's smaller, it's called acute. We've got a 60-degree acute angle, and we've got an obtuse 120-degree angle. Combine them together, and you get a complementary pair, and they will give you a straight angle. After she made her base, down here, you'll notice it's still 5 centimeters. Then she created or found the angles there and there. And then she made a mouth, dotted the eyes, and then put in some hair. Oh, I forgot the whiskers. And the nose.
The baby cat. Mr. Dopey, what's going on?
Welcome back. Okay, so you're paying attention. Now remember, when you're creating a polygon, you have to start with a nice flat base using your ruler with the right dimensions. Then you find the two angles. So you start with your base. Once you have your base, and it's the right dimension, the right length, using a ruler, then you find the two inside angles. So you would need to know an angle off of this side and an angle off this side. Because the angles will determine where those side arms go. The question is, how do you find out where those angles go? How do you know? Like which direction it goes. So we're going to move into that now. Let me see if this is going to work. Alright, so the first thing is to create a straight edge line using a ruler. So we're trying to construct, I'm just going to copy this one as a practice. We're trying to construct triangle ABC. So side length AB is 6 centimeters, side length AC is 5, and side length BC is 4. They don't tell us at all what the angles are. Do you know what the angles are? Are any of them going to be the same?
No.
How do you know?
It's a scalene triangle.
How do you know it's a scalene triangle?
Because a scalene triangle basically it means that all the sides are different lengths, and it says 6, 5, and 4. That's not the same value. So then scalene triangles don't have any lines of symmetry.
Now do you see the value of the last assignment?
And
Yeah. Wait. What? That's fine.
The last assignment was directly associated with attributes of triangles and polygons. Trying to find general rules that we could apply all the time, and you just applied one of them. Everybody following? That assignment has been returned, by the way, so corrections need to be made as soon as possible. Gersher?
And I had also made this hypothesis that because in the dictionaries I had checked, it had said that the sidelines are different for a scalene triangle, and then I made a hypothesis that when the sidelines are different, the angles have to be different. And then I tried it out, and it was correct.
Okay. So related to that, let's see if we can create this shape and prove that all those angles should be different. Okay? So first off,
Is this workspace?
we take our ruler and we make sure that our measurement, which just disappeared, okay, the base has to be 6 centimeters long, right? That's okay. All right, so 6 centimeters long. Does that look right? Now, my ruler is in millimeters, my digital ruler. So it says 60. 60 millimeters, does that equal 6 centimeters?
Yes.
Okay, so now that that's done, how do I do AC is 5 and BC is 4? Can I just draw them and then try and connect them? Like, watch this. So I'm going to make line segment AC. And now I'm going to make line segment BC. Good? Okay, so now if I grab my line segments, how do I build a triangle from it? How can I use my protractor to help me connect them so that I can make this triangle here? Like, do you have to have a compass to do this? Yes?
You could use like protractor. You wouldn't really use the protractor right now because you don't know the angles. No, but you could measure the angle in the triangle and then put it onto the one that you're making right now.
How?
By like using the protractor and on step 3, the picture that they show you of the scaling triangle, you can measure the angles from it, and since no matter how like you can make the shape bigger, only the side ends will change, the angles won't change. And this is what
Do we have to take this thing and move over out?
Okay, so just stop for a second, just to review. Once you create your baseline, and your baseline is the proper dimension that it should be, which is, in this case, 6 centimeters, then you take your compass tool, and the second side length needed to be 5. So you grab your compass tool and open it up and measure it on your straight ruler so that the space is 5 centimeters. Grab your pointer, put it on one corner of your first line, and then you have to draw your arc. Every point on that arc, from point A to the arc, represents a distance of 5 centimeters. It is perfect when we do it digitally. When we do it manually, it can be equally perfect, but you have to take your time, make sure your pencil is sharp, and make sure that the attachment is tightened so that the arms won't wobble when you're arcing. Again, more weight on your pointer, a little bit less weight on your pencil. You don't want to break the lead first, and you don't want to over push on that arm, otherwise it'll start to wobble and the arc won't look perfect. Okay? The next step is to create the second arc. And the second arc for this example must be spaced at 4 centimeters because the other side length of your triangle or your polygon has to be 4 centimeters wide. So we've got a 6 centimeter side, a 5 centimeter side that's prepped, and now we have to do a 4. So let's get that arc drawn. So for the next step, we have to take our compass and reduce from 5 centimeters to 4 centimeters. Now this is where it gets a little different because you have to take the pointer and you need to put the pointer on part B. Well, not part B, but you have to put it, do we put it here? If we put it here, what happens to side length AB? Does it get bigger or smaller? Do we want it to stay the same or get bigger or smaller? We need it to stay the same. Where do we need to put the pointer then? Can we put it there?
No, at the end of
That's right. So we put one over on A before, and that created our 5 centimeter long section, or arc. Now we have to put this one on B, so that we can create our 4 centimeter arc. Right? Uh-oh. My compass moved. That's going to happen to you too. Look, the size has just changed. What does that mean? Do I just keep drawing?
No.
Eric?
Measure again.
Go back and get the 4 centimeter set. You've got to make sure it's accurate before you start drawing. If it's not accurate and you start to create your arc, it's not going to work. So grab your 4. Once you've got it, put your pointer right where it belongs, and then draw your arc like crazy. There you go. Super fast. There's a whole bunch of things on the screen, but there's no polygon. How do we build a polygon from what we see? Dan?
You connect the point A to point C where the two arches meet.
Ah, so that's our point C. It's there. We just haven't recognized it yet. You're right. And now where do we get side length CB? What do we do?
Just move from point C to point B.
And now we've got our polygon. Does everybody follow? This one is exactly the same as the one in the book. Scaled differently, but because we used the compass, it's precise. The angles are identical, and we can check that with a protractor too. Okay, quiet please. So just to sum it up, we should be able to use our protractor once our polygon has been created to find the angles that are missing, or the angles that we don't know. But using the properties of the triangle we are aware of, knowing that this side length is 6 centimeters, this side length is 5 centimeters. Now I remember that's 5 centimeters, but I can also check it. I can check it using my compass tool again, or I can check it using my ruler. But remember, my compass tool, you may have a second one that has 2 pointers on it. You can open that up, put one pointer at one point of the line, one pointer at the other, and then bring your compass tool over to your ruler, just to double check what that side length actually is. Oh yeah, it's 5. Then you can remember how to label it. I would suggest labeling your sides as you finish them, so that you're not confused. But as Krishan mentioned, this is a scalene triangle. It's scalene because all the side lengths are different. And we've just guaranteed or added more justification that it's scalene because all of the angles are also different. But here's the level 4 extension that some of you missed on the last assignment. I want you to remember it because you saw it in the air hockey table, but you didn't make the connection to the two. The angle that is the largest is directly related to the largest side length. The angle that's the smallest is directly related to the smallest side length. And the middle goes to the middle. Do you remember that? How is that related to anything in real life? How can that help construction workers or engineers or architects? Knowing that general rule, how would that help them? Gersher.
It could help them because, like, if they know that this one angle, they know that it'll connect to the. If they know all the angles, and they know that it'll connect to the medium side, then they can create the structure more easily, because then they wouldn't have to set up the side ones.
Can you give a specific example? Alex.
If they needed to find the middle, when you draw the line, like probably where they all meet, that's the middle.
Center of gravity.
So since angle ABD is given, which is actually just angle B, once you've created side length BD, you're able to put the angle in manually. You can use a protractor for this one. You don't have to use a compass to show that one. all you have to do is put your protractor center vertex on point B, and then mark where 120 degrees shows up somewhere. Just put a dot on your page. But you have to measure your baseline from side length BD up and over. Right? Use the same techniques I've shown you in the triangle construction to build the rest of this polygon. So with the parallelogram, you don't have to use your compass. You could, but it's not necessary. Everybody follow?
Let us use our compass or
Well, see, this is where it gets tricky. On your assignment, you have to bring all of your tools. And you need to know which tools would suit the purpose best, or suit the needs best. Because technically, if you choose a different tool, it might not be as accurate.
and it might take you more time.
It may take more time. You want to choose the most efficient way to solve the problem.
To bring the most correct way too.
Exactly. All right? So tool choice is important for efficiency and for accuracy. But you won't know without practice. So please practice this and build your polygon.